Suppose you have a dog and you're trying to teach her how to play fetch. You might yell fetch and throw a ball, but the dog doesn't have a clue what's going on. How do you get the dog to learn how to play fetch? Well, I'm not a dog trainer, but you might do this by, say, whenever the dog does something that gets closer to the desired goal, such as inching closer to the ball, you say something that might induce a positive emotion to the dog. And doing this unconsciously teaches the dog that going after the ball makes the owner happy. And that ultimately, when she brings back the ball, she gets rewarded with a treat. If the owner keeps doing this over and over again, the dog becomes trained to play fetch. Now, if we replace the dog with a machine, we have machine learning. It sounds silly, but really, in essence, that's what machine learning is. Machine learning is using existing examples to make a prediction about an unknown. But instead of teaching it how to fetch a ball, though it can do that, what if we can use the machine to do more real-life problem-solving things like prediction, like predicting when it's going to rain based on observations on cloud formation, temperature, humidity, and etc. Classification, like a self-driving car classifying whether the object in front of the car is a stop sign or a human, so it doesn't run over the human. Clustering and segmentation, dimension reduction, anomaly detection, optimization, and more. Ultimately, machine learning is what we use to help us humans make decisions. But why should we trust a machine more than our human judgment? Well, what if I told you humans are actually really bad at making decisions? Let me give you an example. Suppose I'm an average New Yorker looking for my next place to rent. There's two units that I'm considering, Unit A and Unit B. Of the two, what will you choose? Well, in this case, my answer is probably very simple. I'll choose Unit A because it's cheaper. Let's add two new variables to consider and two more units. Now, which unit should I choose? Is the answer clear? Probably not anymore. And we add two more? What will be my best answer here? When there's multiple options to choose from with multiple factors to consider, it turns out that the human brain struggles. In reality, it's much more complicated than 6 columns and 6 rows. There's probably dozens of other factors you might consider and hundreds or thousands of options to choose from. We can't objectively decide whether a listing is better than another. Our human brain just isn't designed to make good decisions with large data. Turns out, our modern computers are exceptionally good at looking at many things at the same time, and they're very quick at it. A machine that has learned thousands of home listings and which ones get more clicks or more requests for tour can objectively put scores to these listings and pick out the winner. That's how companies like Zillow or StreetEasy are able to recommend listings for you. This is why machine learning and everything that comes out of it is so important. It leaves the most difficult thing to humans, making a decision, to the machine. But a machine doesn't exactly have a brain, so how does it learn? Let's go back to our dog. Earlier, the dog was able to learn to fetch a ball by recognizing that whenever she chased after the ball, her owner would show excitement, which the dog thinks is a positive emotion. Whenever she picked up the ball, her owner would again show excitement. And when she returned the ball to the owner, she would be treated. And this is repeated several times. So the next time her owner throws the ball, the dog has learned that if she fetches the ball, she'll be treated. This is, in essence, reinforcement learning. In machine learning, this concept also exists. You prime a machine with rewards. In fact, at large, there's 3 schools of machine learning: supervised, unsupervised, and reinforcement learning. Supervised machine learning is when labeled examples are used. You keep telling the machine that these are pictures of apples, and eventually when it sees a new image, it'll be able to associate it with an apple. This is the most fundamental type of machine learning and where we'll spend most of our time in. Unsupervised learning doesn't have these labels, but it allows the machine to characterize the apples and tell them apart from other fruits. So I still haven't explained how a machine learns. Just showing a machine a bunch of pictures of apples and bananas doesn't magically make them able to tell them apart. Ironically, in order for a machine to learn what is right, you first have to tell them that they are wrong. Or more precisely, how much wrong. This is known as error or loss. The machine learns by learning to minimize loss. Let me explain with one of the simplest examples of machine learning. Even if you're just starting to learn about machine learning, you might already be familiar with the term linear regression. Linear regression is one of the most widely used statistical techniques in many industries, and it's a simple model that estimates a relationship between two variables. Despite the fact that many people use linear regression, not many of them know that it's actually an example of a machine learning algorithm. For example, let's say we have 10 New York City apartments again. These are the unit sizes and the prices of 10 one-bedroom apartments. Knowing only this information, if we have an 11th unit with its size being at 1,000 square feet, what would you reckon its price be at? Well, we can already kind of see a pattern, right? Most people would predict this unit to be priced at around $3,200. We can estimate this because we know how to do linear regression mentally by looking at this graph. What you probably did is draw this line of best fit in your head across the points and saw where on the line the 1,000 square feet lies. You used previous existing examples to make a prediction about an unknown. But hold on, this is just an estimation. How do we accurately draw this line of best fit? To answer this question, we have to bring in the concept of error. Let's zoom in a bit. If we draw vertical lines between individual points into the best fit line, these are what's called residuals, or basically another word for error. And it's the difference between the predicted and the actual. Well, to be more precise, you may use more formal calculation, like the mean squared error, which would be the sum of that squared and take the average. There are other ways of looking at error, but fundamentally you get the point that this line is where the red lines that represent the differences between the predicted and actual are minimal. So this line of best fit is the line that minimizes the error. And although in our example we can derive the best prediction mathematically, in real life there's a lot more uncertainty involved. And this concept of minimizing the error in uncertainty is super important in the fundamentals of machine learning. Minimizing error is what makes the model learn, and finding ways to optimize this is essentially how we improve and develop new machine learning models. And you'll be doing that constantly over the machine learning journey that you are about to take.